Erin runs a concession stand for a high school football game. She wants the prices to be whole dollar amounts that already include the 6% sales tax. So it says for each item, the price for the customer is given with the sales tax included. So what is the actual price of each item before the tax is added? So when I think about this, I think about if I have $12 and I already have the 6% tax added, then I can say that I know that the price is going to be less than 12 or less than $2 if I take the tax out, right? So the way I would think about it is I have some price for the regular hot dog, so I'm just going to label it H. So that's the price of the hot dog before tax. Now, what do I need to multiply this by to get up to the $2?
6%?
Right. So we have a 6% increase, so the multiplier would be 1.06, right? So I would say this 6% increase to the original price of the hot dog is going to equal the $2 that it costs after that tax, right? So just the original price of the hot dog raised by the 6% sales tax is going to equal the $2. Okay. So this is something we haven't really encountered before, right? So we have a multiplier in front of some variable, and that's equal to some number on the right. So I want to get this variable by itself so I can find out what the original price is. And the way I can do that is just doing the inverse operation of what we see. So the inverse operation here, if we're multiplying here, the inverse is just dividing, okay? So what I'm going to do is I'm going to divide both sides by 1.06. And the reason I'm doing that is because I'm dividing by 1.06 over here, so these two will cancel, and then I'll get some answer on the right side, right? So I just get H on the left, and on the right, I get 2 divided by 1.06.
1.89?
Yeah, I get 1.89, right? So 1.89. So the price of this hot dog before tax is $1.89. So I'm just going to write that just right beside the lettering. Right. And I can go through this same process of this, and I can do that for every single one of these, right? But instead of having $2 on the right, I have $4, right? Or the next one I have $1, and the next one I have $3, and so on, right? So what I'm going to do in this process for each one is I'm just going to divide this amount by 1.06, which is the sales tax. Right? So if I do $4 divided by 1.06, we get $3.77. If I do $1 divided by 1.06, we get 94 cents.
I have a question.
Yeah.
Why can you not just multiply it by the 94%?
Sure. So that's like a 6% discount, right?
Right.
So the reason you can't do that, and let me try to explain this well, I guess. So the reason you can't do that, maybe we can just do an example. Let's do that on the first one, right? Let's do that on the first one.
Okay.
So if I do $2 and you just want to multiply it by 0.94, right? Because that'd be the 6% discount, right?
Yeah.
So $2 multiplied by 0.94, we get $1.88, right? That's
Yep.
just from my calculator, which is a different price than the one we get here, right? And the reason that is because your $2, if you do a 6% discount, it's kind of like that one that we had where you wanted to see if, what was it? If you take $10 off, which will it be greater than? Or if you take 10% off, which will it be greater than? At like certain price points. So the 6% discount is actually more because you have a higher price than the multiplier for the tax, if that kind of makes sense. You could also look at it is if we do 1 over 1.06, so if we do like that, that's not the same thing, so that's not equal to 0.94, right? Those aren't the same thing. If you try that in your calculator, you're not going to get 0.94. So this, dividing by this isn't the same thing as a 6% discount.
Okay.
Does that kind of make sense?
Yes.
Okay. Yeah, so if we divide that, we actually get 0.9433, so on, right? So it's not the exact same thing as a 6% discount. So, okay. Okay, so where was I? Okay, so we did the first three, right? So the next one we divided by 1.06, which is the $3 one.
283.
Yep, so we get 283 for that one. And then the last one, you have $5 divided by 1.06, which is 472. Okay. Yeah, so that makes sense. Okay. Any questions on the first one?
No.
Okay, cool. Okay, so we're going to do something similar for the rest of the 2.11, right? So the next one says Eli says that he only needs $225 more in his account to reach the $1,875 necessary for a down payment on a car. So it says how much is in his account now. So the first one says solve the problem numerically. So this is probably what you'll do if I had to guess. So to solve the problem numerically, basically what you're saying is that we need $1,875, right? So we have that number, and we need another $225 more. So how can I use that number in the $225 to find out how much is in his account now?
I subtracted the 1,875.
Yep.
I subtracted 225 from that. Yeah.
Yep, absolutely. Yeah, so if you wanted to solve the problem numerically, you would just subtract them, right? So we have $1,650. Yep, that's exactly correct. Okay. If I wanted to solve it algebraically, so we're going to introduce a variable here. So I'm just going to say, let's say S or M for how much money he has in his account. So I want to say the money that he has in his account plus the $225 that he needs is going to equal the $1,875 that he needs to make this down payment, right? So the money in his account plus the $225 is equal to the down payment that he needs to reach, right? So if I wanted to solve this equation, all I need to do is get M by itself, or whatever variable I have by itself, and I can do that by just subtracting 225 on both sides, right? And this looks very similar to my problem that I did numerically, right? I already subtracted these two, right, on the right side. So my M is going to equal to 1,650. Right. So this problem was pretty easy as far as the numbers, but as you get more complicated, or as you're just given these problems like this right here, you'll start to need to solve it yourself, right? So you won't always be given a problem as easy as this. Okay. Okay. Any questions on this first page?
What was the algebraic expression? Was it M plus?
Yes. So your algebraic equation. So in equation, you always have an equal sign, right?
Right.
And basically, what algebraic means is you introduce a variable, which is
Okay.
M in this case. So
Okay.
this whole thing is your equation. Yep.
Gotcha. Thank you.
Yeah. Any other questions on this page? Okay. Okay. So the next one we have, it says you watch a show in which people compete against each other to lose weight. The trainer exclaims, down 7 pounds in 1 week. So on a screen behind, the contestant sees that his current weight is 168 pounds. So what was his weight last week? So how would you solve this problem numerically if you just want to use 168 and 7?
168 plus 7.
Right, so you would just add the 7 pounds to show what his weight is last week, right? So we just do 7 plus 168, and we get what, 175? So he's 175 pounds last week. So if we wanted to solve that numerically, or not numerically rather, if we wanted to run an algebraic expression, or equation rather, I'm going to label P for pounds. And what do I want to do with that? So this
Add
pounds,
7. P plus 7 equals 168. No, P minus 7 equals 168.
yep. So the amount of pounds that he was last week minus the 7 pounds he lost over that week is equal to the 168 pounds that he's at right now, right? And what we can do is we can add 7 on both sides. And then the pounds that he weighed last week is 175. Right? So I guess that's kind of part C as well. So as you'll notice, whatever we're doing numerically, if we're adding here, we're going to do the inverse of that for the algebraic equation, right? So if we're adding here, we're going to subtract here. So if we're multiplying, instead we're going to divide in the equation, and so on, right? So what we call these algebraic equations, we call these one-step equations. So that's the next part. So we call them one-step equations, and basically that means that we can isolate or make the variable by itself in one operation or one step. So like in the example here, we just added 7 on both sides. In the example that they give down here, where they have x plus 5 equals 12, they just subtract 5 on each side. So one-step equation, you can get a variable by itself in just one step. Okay, any questions on this page? Okay. All right, let's try another one. So this one says, your email account states that you have 3.36 gigabytes, or 21% of storage space has been used. So it says how much total storage is allotted to your email account. So the two numbers I'm going to use is 3.36 and 21%, or as a decimal, that's 0.21. And how can I solve this numerically? So I know that percentages are usually multipliers, right? Multipliers are dividers. So I'm probably going to use that operation here. So does anybody have any idea on how I can solve this? And
So S would be the variable representing storage.
Sure. So
Times 1.21 equals 3.36.
yeah. So let's do it algebraically then, because I think you're on the right track. So what variable do you want to use?
S for storage.
S for storage. Sure. So we have 21%, or 0.21 of the storage is going to equal the 3.36 in the storage, right? So maybe that's a little bit more intuitive way to think about it rather than the numerically, right? So what can I do to solve for S here?
Divide 0.21 on each side.
Yeah, just divide by 0.21 on each side. Right, so we get S by itself on the left side. And on the right side, what do we get? I'm getting 16 exactly. So the amount of storage for your email account is 16 gigabytes, right? So I think that that is probably a more intuitive way of thinking of it, rather than A, where we just divide by 0.21. So we had 3.36 divided by 0.21. So yeah,
I think I overthought. I completely skipped over A, didn't I?
Yeah, no, and that's fine, right? Because that's the way that we kind of want to start thinking about this, because when we go into like the next section, or at least the next two today, all we're going to do is solve these equations like this, right? So the way that I really want everyone to start thinking about when we're solving these problems is to write these algebraic equations, okay? Okay, so we wrote the algebraic equation and we kind of solved it as well. So part C is included in that last one. So yeah, so that was good. So what about the next one? So the next one says, you're reading the newspaper and you see home value assessments. Your house is listed at $42,340, but the assessments are 1/3 of the true value of the home. So it says, what is your home worth? So what's our variable here going to be, and what do we want it to represent?
That's the variable to be, gosh,
So what are we
any for
trying to
assessments.
solve?
The value of the home?
Yeah, so we don't know the value of the home, right? So I'm just going to label V for value. So we know what the value of the home. We don't know exactly what that is yet, but how can we solve for that? So how can we solve for the value of the home? What equation can I make? Or I guess, what are the two numbers that I can use to make an equation?
0.33 or 1/3, and
Yep.
then 42,340.
Yep, so I have these two numbers, and what relation do they have to the value of the home? Or in other words, what should my equation look like?
33V equals 42,340.
Yep, so 1/3 V, so 1/3 the value of the home is equal to $42,340, right? And now I can just solve for the value of the home, right? So how do I solve for V?
You got to get it by itself, so
Mhm.
you're gonna divide 1/3 on each side.
Yeah, so if I have 1/3, and I'm going to divide that by 1/3, so if I have two fractions like that, what can I do to change that into multiplication?
Invert the 1/3 on
The second one,
second
yeah.
part.
Yeah, so I just flip and multiply. So I have 1/3 multiplied by 3 over 1, right? So instead of dividing both sides by 1/3, I can just multiply both sides by 3. Right? So either one works. It'll show you the same answer in your calculator. But I'm just going to multiply both sides by 3. Right? So we just get V on the left, and we get some 6-digit number on the right.
127,020.
$127,020. So that's the true value of your home. Yep. Awesome. Anyone have any questions on this page? Okay. All right. Let's go on to the next page then. So, what if I have the next one? So it says only 2/3 of the class was present on a Friday. If 16 students were present, how many students are in the class? So the first thing I see is I have 16 students that were present on Friday, and that was only 2/3 of the class, right? So I know that I'm going to make an algebraic equation again. So I have an equal sign. I'm going to need some variable. So I'll just label it S for students. And this S is specifically the students that are in the total class, right? If they were all there.
Right.
So what equation can I make with 2/3 and 16 students?
2/3 S equals 16.
Yeah, 2/3 of the amount of students in the total class is equal to the 16 students that were present on Friday, right? And then to solve for this, I can either divide both sides by 3/2, or I can just multiply, or rather divide by 2/3 and multiply by 3/2. Right, so I can just multiply both sides by 3/2. We'll just get 1s on the left. And on the right, all we need to do is multiply 16 by 3 and then divide by 2, right? So 16 multiplied by 3/2, and we get 24. Right? So what that's saying is, total in the class, there are 24 students. So if they were all present. Okay. All right, the next one says a homeowner will have enough patio pavers to cover a 200 square foot patio. He wants the patio to be square. So it says, what will the dimensions of the patio be if he wants to use all pavers? So it says, state your answer in feet and inches, such as 5 feet and 6 inches. I'm not worried about the last part as much. We'll just answer it in feet so we don't have to do any conversions. So we'll just answer it in feet. So I want to draw a picture representing this.
But what if we did want to do it in inches? So we would know how to convert from the from the inches into feet or back and forth.
Sure, yeah. So I can show you how to do that after we get
Okay.
the answer, okay?
Okay, thank you.
That's not a problem. Yep. Okay, so what we need to do is we want this patio to be square, right? So let's make a square patio. And I don't know the dimensions of it, right? I don't know the length and the width, right? Because that's what it's asking me to find. So I'll just put length over here, and I'll have width across the bottom. So this is my width, this is my length. And what do I know about my width and my length, according to the problem? So I specifically want the patio to be square, right? So what's special about the length and the width of a square?
They're the same.
They're the same, right? So instead of having L and W, I can just have L and L, right? Because they're both the exact same. So I'm going to replace the W with an L. So I have the length times the length is going to equal the area of this square, right? And what's the area of this square?
It's L times L squared.
Right, so L times L is L squared, right? So that's what my variable is going to be. So L squared. And what's that equal to?
200.
200, exactly. So the area of my patio is 200 square feet. And that's equal to L times L, or L squared. Yep, so we just built our equation, right? And does anybody know what the inverse of squaring something is?
Square root.
Yeah, square root. So I'm just going to square root both sides. So the square of a square root is just L in this case. And the square root of 200 is 14.14 feet, right? Because we're looking at this and specifically in feet, since that's what we know that the area is. Okay. Okay, so we've solved for that in feet. So if I want to solve this for feet and inches, do we need to change the 14 feet into anything?
Yes.
So,
Oh, yeah.
so yes and no, right? So if we want to change it into all inches, we would need to know how many inches are in 14 feet, right? But the problem specifically asks for feet and inches. So we can leave the 14 feet alone, and we can just change the decimal into inches, right? Because it's not even a full foot, that 0.14. How can I change 0.14 into inches?
Times 12?
Yeah, so I just need to multiply 0.14 by 12, right? So 0.14 times 12 is 1.68. So what I would say is this is 14 feet and 1.68 inches. Right, so we're just multiplying the decimal part by 12 inches, which is just our conversion, right? So if I wanted to...
but how would you show it in this equation, though? How would you show that I multiplied something and then I ended up getting this answer and then I had to divide it?
Sure, so what I would say is, remember back when we did the conversions where we did like this...
Right.
Yeah, so you could just write it off to the side where you have 0.14 feet over 1, and then you can multiply that by 12 inches over 1 foot. Right, so something like that. So we know that the feet cancel.
Oh, okay.
And then you're left with the 12 inches multiplied by the 0.14.
But it's in parentheses, so okay, gotcha.
Yeah, so this just kind of shows your work that you are changing the units on the decimal part. Okay.
Thank you.
Yeah. Any other questions on that one? Okay. Okay. So I'm gonna get my my drawing skills tested again. So this one says, after building the patio, the homeowner is planning to build a cube-shaped bin to hold compost. So it needs to hold 5 yards of compost. Then it says, what will the dimensions be in feet and inches? Okay. So this time, instead of dealing with a square, we're going to deal with a cube. So what is special about a cube? So what's special about a cube?
It's multiplied by 3.
So the sides are, or I guess what's special about the sides of a cube? I think you're on the right track.
They're equal.
Yeah, they're equal, right? So this length here, or this height, I guess, is equal to this one over here, right? So this is also the length. So this is, if we were just looking at like the patio up here, this is just like the front part. And then we have to look at the depth of it, right? So this part back here, which is also equal to L, right? So how can I find the volume of this cube?
Well, we know it has it needs to hold 5 cubic yards.
Yep, so I know it's going to
So-
equal to 5, right? So
Well-
my equation's equal to 5.
Wouldn't it be 5 cubed
No,
after the third power?
it's not 5 cubed, but it's L cubed, right?
Oh,
Because that's our variable. So the
Okay.
length times the length times the length is equal to the length cubed, and that's equal to 5 cubic yards.
Okay.
Yeah, so L to the third power equals 5. Right, so that's
Okay.
just the volume of this cube. Yep. So we have that, and we know that it's a one-step equation, right? We only have to do one thing. So how can we undo this third power? So if I'm saying it's L cubed, what's the opposite of cubing something? Well, if I'm squaring something, the opposite is a square root. So if I'm cubing something, the opposite is a cube root. So I'm just going to put the square root symbol again, but instead I'm going to put a little 3 where the check mark part is. So I put a little 3 right there. And that just means you're taking the third root of it. Right? And I can do the same thing on the other side. And put a little 3 there. And that just means I'm taking the cube root of 5. So I know these are inverses of each other on the left side. So I'm just going to end up with L on the left side. But then we run into a problem. So personally, I don't know how to do cube roots in my head. But we have a function on our calculator that can do that for us. So what I can do is I can go to the math button. So it's the third one down. And go ahead.
Are we rounding to any decimal point?
Yeah, we'll round to the third one. So I'll click, it's option 4 for me, so which is the cube root. And so I get the cube root, and I just have to put the number 5 in there. And I get 1.709. So it actually round up to what? 1.71. So it'll round up to 1.71. And that's yards, right? Because we were in cubic yards, so we have to end in yards. But it asks, what will the dimensions be in feet and inches? So how can I convert yards into feet?
Multiply by 36.
That's if I wanted to go straight to inches, right? So we could do that.
Oh,
Yeah, let's do that.
I'm sorry. 3.
You're fine. Let's do the inches route. I like that better, actually. So let's multiply this by 36. So 1.71 and multiply that by 36. So 1.71 multiplied by 36 inches. And we get let's see. I'm getting 61.56 inches. Okay. Does everyone agree with that so far?
Yes.
Okay, cool. So now how can I change the 61 into feet?
Divided by 12.
Yeah, so if I do 61 divided by 12, we get 5.083 repeating, right? We get this long number?